Hi everyone, and welcome back to Maths and Physics with assignments. Now we're doing the fifth of 7 videos, and this is the last that form part of grade 11 revision before we look at grade 12 compound and double angles. Alright, it's also one that's controversial: determine general solution using factorization. For some odd reason, factorization is a problem that you'll experience, but hopefully, yes, you can follow and understand. Right, so problem 1, they've given us, so they want the general solution, given me 2 sine squared theta plus 3 sine theta minus 5 equals 0. This is similar to us saying let sine squared equal to x. So this is the same. You should be able to see 2x squared plus 3x minus 5 equals 0. Just instead of x, we're giving you sine, and you have to be able to factorize with sine. Now this one is relatively simple because 2 and 5 are both prime numbers. So 2 only has the factors 2 and 1. So 2 sine squared come 2 sine theta times sine theta. Alright, 5 can only become positive 5 times negative 1, which gives me negative 5. And if I test, I have 5 sine squared. If I multiply the two closest to each other, 2 times negative 1, the two furthest items, gives me negative 2. So 5 minus the 2 would give me the positive 3. So 1 mark if you correctly factorized. Alright, so there, x, that should have read, if it was that equation, 2x plus 5, x minus 1. Now we apply the zero factor law. We make each bracket equal to 0. So 2 sine theta plus 5 equals 0. Sine theta minus 1 equals 0. If I take 5 over, it becomes negative 5, and we divide by the coefficient of sine. It gives me negative 5 divided by 2. Take negative 1 over, that becomes sine theta equal 1. Now, according to when we draw the graphs for sine theta, the coefficient here is 1. So therefore the amplitude is 1. So my range, sine theta, is less or equal to 1 and greater or equal to minus 1. Right, it cannot go bigger than the value 1. So therefore, for this one, we have no solution. On this side here, shift sine 1, I get a reference angle of 90 degrees. Right, so sine is positive. Which quadrants is it positive? Quadrant 1 and quadrant 2. Right, so in quadrant 1, theta equal 90 plus k times 360. Quadrant 2, 180 minus 90 plus k times 360. 180 minus 90 would give me 90 plus k 360. Right, so 1 mark for correctly factorizing. 1 mark for getting the two proper equations. Here, mark for the reference angle and noting that there's no solution for that side. 1 mark for creating the two equations, and another mark for simplifying. So go check which of these meta marks you can get. Check where you've gone wrong. Correct your errors. Do it over and over till you can do it properly. Right, let's look at problem number 2. Right, for problem 2, we're given determine a general solution. 2 cos squared theta plus sine theta cos theta minus 3 sine squared theta. Right, so 2 cos squared theta, because 2 is a prime number, can only become 2 cos theta times cos theta. Minus 3 sine squared theta, because 3 is a prime number, can only become 3 sine theta times sine theta. Alright, the sines we choose based on the middle term, so therefore the biggest value I've made positive. Right, so if I multiply 3 times 1 gives me 3. If I say 2 times minus 1 gives me negative 2. 3 minus 2 would then give me the plus 1. If we apply the zero factor law, now I have 2 cos theta, and if I take 3 sine theta over, minus 3 sine theta. Alright, we always divide in such a way that we're going to get the quotient identity, tan theta, so therefore I divide by cos. Cos theta divided by cos theta cancels. Sine theta divided by cos theta would give me tan theta. Also need to get rid of the coefficient, so minus 3 divided by negative 3 gives me 1. And there 2 divided by negative 3 gives me negative 2 over 3. Press on my Casio, shift 10 minus 2 over 3. I get a reference angle of 33.69 degrees. For the second one, if I take negative sign over, it becomes positive sine theta. So cos theta equal sine theta. Again, I'm going to divide by cos to ensure that I end up with 10. So sine theta divided by cos gives me tan theta. Cos divided by cos gives me 1. And if I say shift 10, 1, get a reference angle of 45 degrees. Right, so if we come to the first one here, tan was given as negative. It's negative in quadrant 2 and quadrant 4. So in quadrant 2, 180 minus the reference angle plus k times 180 gives me 146.31 plus k times 180. K element of integers. For quadrant 4, 360 minus the reference angle plus k times 180 gives me theta equal 326.31 plus k times 180. Here 10 is given as positive. It's positive in quadrant 1 and in quadrant 3. So theta equal 45 plus k times 180. In quadrant 3, 180 plus 45, which gives me 225 plus k times 180. K element of integers, k element of integers. So 1 mark for correctly factorizing. 1 mark for correctly simplifying using the zero factor law. 1 mark for the correct reference angle. 1 mark for both equations. Another mark there for both equations. And then 1 mark for the solutions. Right, so if you follow, let's look at problem number 3. Now, problem 3 says determine a general solution given 1 plus 2 sine theta cos theta equals 0. Right now, here specifically, we're trying to catch out the value 1. Should see that I have sine theta cos theta, so that means 1 must be written in terms of sine and cos for me to make it a quadratic equation. So according to the square identity, 1 is the same as sine squared plus cos squared. Right, and I know I'm using sine squared and cos squared because I have sine and cos in the middle. Now I factorize, I have sine times sine, get sine squared, and I have cos times cos, cos squared. All the terms are positive, therefore my signs are positive. So apply the zero factor law, I have sine theta equal negative cos theta on both sides. Right, I'm going to divide always by cos, because sine divided by cos will give me tan theta. So I make it a single trig ratio instead of 2 trig ratios. Negative cos divided by cos theta gives me negative 1, and I've done the same thing there. If I say shift tan positive 1, I get a reference angle of 45 degrees. Right, now tan is negative in quadrant 2 and quadrant 4. So for quadrant 2, tan would simply read theta equal 180 minus the 45 plus k times 180. K 180 because I'm dealing with tan. 180 minus 45 gives me then 135 plus k times 180, k element of integers. Quadrant 4, 360 minus 45 plus k times 180 gives me 315 degrees plus k 180. So 1 mark for standard form, 1 for factorizing, 1 here for simplifying and finding the reference angle, 1 mark for creating the equation and simplifying, same there. Right, so I hope you follow. I wish you nothing but the best. Continue working on making yourself better and become the greatest success you can possibly become. Please like and subscribe so that I know that I'm doing something valuable and I continue doing it. God bless. Bye.